Hello everyone. Me and my team have built an Android app which will be notifying people about the status of their present location. That is whether the person is inside a COVID hotspot or not, or if he or she is unknowingly moving within a COVID hotspot. The person can then act accordingly, which in turn will help to prevent many cases. Hence, this app will be a very effective software solution to fight the COVID crisis. As the time is limited, so without further ado, I would like to start demonstrating the working of the app. What we can see on the screen now is a virtual Google Pixel 3 Android device. This virtual device has all the functionality of a normal Android device. Now I browse the apps menu and open our app. Now I browse the apps menu and open our app. On the launch screen, it asks for the user permissions which are needed to retrieve the device's current location on the Google Maps. We grant the permission. Following this, the app shows our current location on the Google Maps and all the nearby COVID hotspots which are marked as red circular geofences. We now simulate an arbitrary path on the map traveling from one location to another with the help of the location simulator window displayed on the left. When we do not enter any of the hotspots on our simulated route, there will be no notification. However, as soon as we enter a hotspot, an alert text "You have entered a hotspot" will pop up on the screen. Let's see this in action. Again, as soon as you exit that hotspot, another notification "You are safe now" will pop up on the app. Again, we have entered a hotspot. We left the hotspot. So we see that it works. We can also view these notifications on the notification panel just like in a normal Android device. I would also like to demonstrate another feature of our app. This feature notifies the user whenever he or she is moving inside a hotspot by popping up the on-screen notification "You are moving within the hotspot." This can be viewed on the notification panel as well. So let's simulate a random route inside a hotspot and see that in action. So this is our hotspot. Let's zoom in there and zoom in on the simulator too. So if we move within this hotspot, we get this alert text. Again we move inside the hotspot, we get this text again. So we see that it's working. Apart from this, the notifications received will also be accompanied by an alert sound on the actual device, or if the device is in silent mode, there will be a vibration. The app also runs in the background, so the user can receive notifications even if he or she is not on the app. So we have seen the app in action till now, and now I shall briefly explain the code behind this app. The code is mainly in Java with some libraries like Dexter, Location Services, GeoFire, and Google Maps. The app also has Android X support in it. On the left pane we can see the set of all files which together makes the app. The files include some Gradle libraries and a maps activity function which is written in Java. The files include the Gradle libraries and a maps activity function which is written in Java. The dialog requesting location permissions on the launch screen is generated with the help of the famous open source Karumi Dexter library. The GUI is purely designed in Java and is made similar to a Google Maps interface for ease of use. The API key for enabling Google Maps is embedded in the file name Google Maps API.xml, and it can be seen here. The Maps SDK for Android has been enabled in the Google API's console to make sure that the API functions correctly. The user's location is retrieved by a JavaScript which mainly includes three functions, and these functions can be seen here: build location request, build location callback, and fuse location provider client. After this, we read the latitude and longitude values of the hotspots from the cluster database and use them to deploy virtual geofences around the city with the help of the GeoFire library, which enables us to geofence multiple locations on the same map. For the time being, we have hosted the app on Firebase. Now I would like my friend Pijus to continue with the explanation of the database and the clustering model.
So for the testing purpose, we have generated the coordinates of 240 random COVID positive cases in our locality, which are stored in our database. Now this dataset is fed into our clustering algorithm to dynamically select optimum COVID positive clusters, such that all the raw cases belonging to a particular cluster is within 100 meters from the center of the corresponding cluster. Now for implementing this, as you can see on the left side, we have written a small Python program which uses a modified k-means clustering function already built into Python. Normally the k-means function built into Python takes input the dataset of unlabeled data points and the number of groups we want to form, and then it efficiently allocates each data point to a particular group. But in the real world scenario, we cannot assume that the number of groups will be formed will be a particular number. So what we have done is that we run this built-in function starting from 2 groups and then continue for 3 groups iteratively for 4, 5, 6 and so on till we see that the average distance of each data point from the corresponding cluster is within 100 meters. Now I will run this Python program. So this takes some time, so I will skip this till it completes. Now we have completed our clustering process, and let me show you the clusters that has been generated by the system. As you can see that the algorithm has generated here 98 clusters for this set of input. The table contains the coordinates of the centers of each cluster along with the number of cases within that cluster. Now what happens if suppose new cases are found the next day? Then we simply deploy the clustering algorithm again every time and the clusters will get updated easily. Now in the real world, this database will be stored in a cloud server, and the mobile Android application which we have been built will fetch the locations of the center of these clusters stored in our database and deploy geofences. So this was the working of the backend application of our project.